Model Steam Engines for Beginners, Part 17. Vertical steam engines, what the component parts are called and what they do. The obvious difference between a vertical steam engine and a horizontal steam engine is the position of the cylinder, but there's a bit more to it than that. Steam engines were developed over time by various people, and after some weird and wonderful contraptions, which were built mainly due to Boulton and Watt's patent on their system, as time went by, things settled down and engines became either vertical or horizontal or purposely built into a steam locomotive or traction engine. The engine that's currently on screen is a vertical twin Stewart 5A, complete with twin water pumps. A single Stewart 5A is capable of producing 1.5 horsepower at 80 pounds per square inch. A Stewart 5A is a small full-size steam engine. This is a Stewart 1010, which is definitely a model steam engine because it's a lot smaller. I rebuilt this one recently, and this is what it looked like in episode 1. In its original state, and here it is, it ran quite well. In this clip I'm giving the engine a bit of tender loving care by straightening the crankshaft using a large soft-faced hammer. The exhaust ports really were a mess, and for a while I thought, is it really worth doing this engine? But as I make tutorials, it's yet another example of how to do it. Turn a silk purse into a sow's ear. Well, almost. Here's a rebuilt engine with a straight crankshaft, looking and running far better than it did in the first place. Just like in the last video, here are some labels showing the different parts of the engine. Starting with the flywheel, then the cylinders, then the eccentrics, the steam chest, and the displacement lubricator. On this engine, the crosshead guide is built into the cast standards that support the cylinders. In the previous video, I showed different kinds of crosshead guides, from simple steel bars to a machined trunk guide, and the tangy style of crosshead guide which is built into the casting. This is similar, but it's not exactly like the tangy design, although I suppose it is close because the crosshead guides are cast into the standards. And in common with the horizontal steam engine, it is very important to support the part where the connecting rod connects to the piston rod. The next part of this video was taken from a series that I made about rebuilding a vintage steamboat. I replaced the original 1010 steam engine with one that was not only better made, it had reversing gear on it. Over now to the details of the power plant. This is the original 1010 I removed from the boat. This is what I'm going to replace it with. Regular viewers to my channel may recognise this engine. This is one of the late Bernard Walker's engines. Bernard Walker was a friend of mine and a superb engineer, and the reversing gear I'm going to adapt for radio control. It's a great combination really, a superbly made model boat engine for an equally superbly built model boat. This engine that's running at the moment is a Stewart twin launch engine, a slightly different design. The engine uses 4 pieces of steel bar, which support the cylinders via the lugs that are cast into the cylinders. This column design on a model steam engine is very popular for use in open steam launchers. The crosshead arrangement is quite different as well. Instead of a trunk guide like on the 1010, it's a flat metal bar with a slot in the crosshead. And this works perfectly well. It keeps the crosshead in a fixed position as the connecting rod is trying to move the piston rod left and right as the crankshaft rotates, which is no good at all. I repaired this engine for a customer quite a while ago and it was in very bad condition, but in the end it turned out quite well, and as you can see, it runs very sweetly. You may notice that some reversing gears on engines are different to others. Normally the expansion link is pulled back and forth by a pair of rods or bars each side of the expansion link, but on this engine, and the one in the previous clip, there is only one at each side of the expansion links. I don't think this is a very good way of doing it, but it seems to work on the models. And as you can see, the engine does look quite good. It's absolutely covered in oil because I was rebedding it in after the rebuild. Running in or breaking in any kind of a machine is quite a complicated process, and if you do it wrong, some of the parts may be ruined. I often run the bearings quite slack for the initial running in period and then tighten them once it runs smoothly. This is a Stewart No. 1 steam engine, and it has a very strange arrangement in my opinion. Fitted to the sole plate, which is the bottom part, is a substantial casting that holds the cylinder, but there's only one at one side. And the front part of the cylinder is propped up with a substantial metal bar. It's a very simple design, quite good looking and quite effective. This particular example of a Stewart No. 1 engine is fitted with reversing gear. And as you can see, everything is rigid, nothing's flopping about, and it does run quite well. This is the expansion link bobbing up and down. This is driven by a pair of eccentrics, and reversing is quite simple. All you do is move the expansion link, which just uses the other eccentric, which is 180 degrees out of phase, to reverse the engine. Simple when you think about it. One interesting thing about steam engines, although there are many interesting things about the old steam engines, is how quickly they reverse. There's a steam engine, I think it's in Sheffield, and it's a steel rolling mill engine, and that reverses unfeasibly quickly for its size. I'd like to show you the crosshead arrangement on a No. 1. This is called a slipper guide. The block that fits to the piston rod has two protrusions on it that fit in between two pieces of metal bar, as you can see here. And this type of crosshead arrangement is what you would usually find on a horizontal mill engine. This is quite a good design because if the bars get worn, you can just replace them, a relatively simple job. If you watch this clip for long enough, you will see the relationship between the position of the piston rod and the position of the valve rod. Unless the engine is really badly built, and this one isn't, it's a very smooth movement and quite hypnotic. I made a video quite a long time ago showing lots of bits of metal moving around, similar to this, only a little bit longer. And I think that's one of the things I really like about steam engines. They're external combustion engines, and you can see all of the moving parts inside. This next engine is a Stewart 5A, and this is one that I rebuilt a couple of years ago. The clip is taken from the series Rebuilding a Stewart 5A Steam Engine. I fitted a brand new crankshaft to this engine. It's really well made and it runs beautifully, and it was on my dining room table when a customer called in to pick up another engine that I'd been repairing for him. And he really wanted to buy it, and I didn't really want to sell it, so I put a high price on it, but he still bought it. The good news is I'm about to buy it back off the customer, because I do like this engine. Here's an extract from the video when I explain some things about the lubrication aspect of the crosshead. The lubrication on this engine is very clever. On the top of the crosshead there are two holes, right next to the piston rod. And as the oil that's flooding in down the side of the crosshead guides enters these holes, first of all it meets the crosspin and lubricates that, and then the good thing about it is that the connecting rod is completely hollow, so the lubricating oil runs all the way down the connecting rod and into the big end and lubricates that as well. Fiendishly simple, fiendishly clever. In this clip you can clearly see that the output from the pump, which sits on the oil tank, is connected to the junction by a very short pipe. If I was to use a longer pipe, then I could remotely mount the oil pump somewhere away from the engine. I also fitted a mechanical lubricator which is driven by one of the eccentrics. This engine runs very smoothly and quite efficiently as the steam admission is set to early. And that's why it doesn't knock because the steam is admitted early, it's cushioning the piston at each end of the stroke. I think it's time to go out in the garden. This large twin-cylinder steam engine sat on a picnic table at the side of the Castle Steam V6 boiler is actually two separate 5As connected together on the same mounting. This is a very powerful steam engine and it runs well. The technical spec for a 5A is 1.5 horsepower at 80 pounds per square inch, so I assume that this one must be giving around 3 horsepower running at this speed at 80 pounds per square inch. Here's an extract from the full-length video. A 6-inch diameter Castle V6 boiler is too small even for a single 5A. But with a single 5A and keeping your eye on the water levels and the fire at all times, it would probably power a 25-foot long boat. Steve at Castle Steam was telling me that they sold one to a man who has a steamboat and he rides up and down the canal in it, with a Stewart 5A as the power plant. And apparently at 80 pounds per square inch the boat does about 7 miles an hour, which is quite good. And of course with a twin 5A it would be faster than that, but for very short bursts before the water ran out. With the pump pumping water and the engine running, the pressure drops below 40 pounds per square inch, as you can see on the gauge. You can run the boiler with the blower wide open, but it's not recommended. The fire becomes far too fierce. I hope that this video about a quick excursion into the world of small, full-size steam has been helpful and possibly answered some questions that you may have been thinking about. That's it for the steam test. I'm letting the fire go out, after which I will blow down the boiler to keep it nice and clean for the next run. Dropping the pressure in this state takes a while, but the engine and the pump are stationary, so there's nothing taking the steam out of the boiler, and the residual heat of the fire and the copper keeps the boiler hot. And that's it for this longer than normal video about vertical steam engines. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that you can find other videos that you may like to watch. And by using the playlists you can actually watch the videos back to back.